Hello everyone, I am Abhishek and today we are going to solve palindromic partitioning problem. So let's first go through the question what it says. So given a string S, partition S such that every substring of the partition is a palindrome. Return all possible palindromic partitioning of S. So here in the question it says that if there is a string given as AAB, we need to return all the palindromic partitioning of the string such that each partition whatever we have done like in A or B or AAB, so each partitioning should be a palindrome. So here we can have our gap method. So with the gap method we will be finding all the palindromic substring first, and whenever we found all the palindromic substring, after that we can have a recursive problem with a backtracking such that we will find all the palindromic partitioning. So let's get started. So for gap method I will be needing one dp first. So int n will be I will be having the length of this string. Then we will have the factor of int, we will have the dp and I will make the dp of size n. Then at this point, for how should I calculate the palindromic substring using the gap method? So here I can have my initial condition as for int I equals 0, I less than n and I plus plus. Here we will have our dp of starting from 0 to 0, that means of size 1 h true. So I can have your bool instead of the int, boolean value, and not 0 0 but it should be I and I. Then after having my initial condition I will then start my gap method, or I can avoid my initial condition. Let me first try with avoiding this initial condition first. And in the gap method we go lengthwise, so I will start with length 0 or length 1 till length is less than equals n and length plus plus. Then for each length I will be having the I. So I will traverse through row wise, so row will start from 0 to row will start till n, but on each iteration I will reduce my rows as like one second, for each iteration I should be reducing my rows here. Because in first iteration we will take care of the a and b, and for the second iteration we will be having two strings, so a and ab will be taking care of a and ab. That is I starting from 0 and 1, but I should not go till this because we are only considering two string here. So for that purpose I can have this as n minus l. So as I am starting l with 1, I should make it +1, and here it should be n plus plus, sorry, I plus plus, I plus plus, and then I will be starting my j will be the ending character. So I is my starting character and j is my ending character. So j will have, j's will go till I plus l minus 1, why I plus l minus 1? Because for the first iteration, when l equals to 0, I want to have j equals to I, and for second iteration, as in second iteration we'll be considering two strings, so it should be I plus l, that is I plus 2 minus 1. That means if I start at 0, my j should be 1, so I am considering 0 and 1 as two strings. Then here I should be checking if my I equals to j. If I equals j, then dp of ij equals true. Else if I need to handle the two characters, or I can have, for all other cases I can have only one case. So I equals to j, so this is for the single character, and for all other characters like 2 characters, 3 characters, 4 characters, can I have a same condition? If there is 2 characters, I need to check if s of I is equal to s of j, and for third and more character I need to depend on the I plus 1 and j minus 1 cases. So I need to have a condition for 2 characters, so 2 character condition will be j equals I plus 1. So for this character I will have dp of I and j as s of I equals to s of j. So this will be my condition for else if condition, and for else condition dp of ij will be dp of I plus 1, not like this. So else for all other cases, else if s of I equals to s of j, then for these cases I should have dp of ij equals dp of I plus 1 and dp of j minus 1. So, and for rest all other cases it will be false only, and from the starting only I am making it 0. So from here, with this condition I will have all my palindromes, and from this palindrome I need to partition it. So to partition it I will be having one more function call, that will be recursive function, where I need to start with index 0 and my end will be index n, and I will be passing my dp. And as I need to return a vector of string. I am making just a result here, and the result will be then passed by reference to this function. And the next thing is I can have a current also here of vector of string type. So in the current, I will be having all the substrings which are palindrome. So I will have a current over here and I will pass my current. So I will pass both my current and the result as a pass by reference. Let's make our function. So my function will not return anything, it will be void type, and I will be starting with index and in here int n, then dp of bool. So let's name it as each palindrome, and my result I will be passing it as a reference, and my current, which also I will be passing it as a reference, and we will backtrack it every time. If we don't find any solution, we will backtrack it, or even if we found any solution and tracking back, then we will be removing whatever we have added for that function, and at the end I will be just returning the result. Then in this case my base condition will be whenever my index becomes greater than equals to n, at that time I will need to push back current, then I will return it. I have done the pushback, and the next thing I have to do is I have to check how many palindromes are there. So for this I need to start from index int I equals idx, then I less than n, I plus plus. So after starting from here I will also go through a for loop, or no, for loop is not required. So for this index I will be going from 0 only. I guess there's some connectivity issue. 1 second, let me check. Okay. Oh, so how can I partition it? So for partitioning it I will be checking from the index. So if from here, if for each palindrome from index to I, if it's become true, then I will be having a current dot push back s dot sub str. I will be taking a substring from index, which is my starting index, till the size. So my size would be from index minus I plus 1. So index will be my starting index, and then minus I will give me the length, and plus 1 I am doing because substring. So to get the substring from a index like from I to J, we have to like mark endpoint at J plus 1. So like that, for that purpose I have marked here at index minus 1 plus 1 minus I plus 1. So current I have marked. So we are doing the pushback, and from here I need to call my solve function recursively, and I will pass my I over here, and will be the same, result will be the same, current will be the same, and current dot pop back. So current dot pop back, so I think it should work. So in the for loop, from the starting I am checking here, from the starting it will be, then for every start I am giving here the I as the every start and returning it back. Let's see. Pushback as I haven't passed my substring. Okay, I need to pass my substring over here. I will pass it as a reference. 1 second, I have done something wrong. Yeah, I will pass it as a reference, and here also I will pass my string. That's it. Passing my DP over here. Okay, I have named this as each palindrome. I think I haven't made any compilation mistakes anymore. Let's see. Deadly signal. Stack overflow, it's coming. Stack overflow. What should be the issue over here? I have done it properly. This part, all DP is done and written and everything are done. Result and current solve. Okay, stack overflow, that means it is calling on address this. That means it is not stopping, it is calling a lot of signals over here. So each palindrome from index to I, then current, we are doing the pushback. Okay, it should be from I minus the last index minus the first index and plus 1. It's correct. Should make a substring current vector string I am pushing, then solve and current dot pop back. Good only. If any time it will tell the palindrome. Okay, let me first check if I am making my palindrome properly or not. So it should be command C. Okay, let's make the for loop with int I equals 0, I less than n, I plus plus, and then for int j equals 0, j less than n, j plus plus, and then cout tp I j cout handle. Okay, let me first check if I am making the palindrome properly or not. For A B, this will be palindrome and A is palindrome. Yeah, I am making my palindrome then properly, passing from 0 and dp result this. Okay, then index greater than equals to n, then result dot post back current. Okay, we are doing then from here we are returning back, and here I am partitioning it. Whenever I am finding any palindrome, I am partitioning at its first place and going to the next, and from the next I am checking if there is any other palindromes or not. Till I partition it at this end. And my s.serve str function is also correct. And then also let me have this control 1 second, control Z, control X. So in the string as string stmock, let me give it stmock and this and then CO. So I am only on the A only. Every time it is printing A. Why it's printing only A? So here I am checking from the index from I less than and I plus plus. So from index to I, if I got it, okay, I should not take I should take I plus 1 because I am partitioning at I, so the next starting index should be I plus 1. So I think 1 second, let me see if my, yeah, now I am getting my answer correct. Yeah, now let's analyze the time complexity over here. The time complexity over here will be O n square, we can say, and for the solve it will be, so it's going through all and partitioning it at all the points. So if there are, like, for suppose 3 character, so we are partitioning it 1 2 3 times, so 2 to the power of 3. So here it's 2 to the power of n. It's a exponential time complexity and we are given the length as 16. So will it work for exponential? Let's try submitting it. If it doesn't work, we have to think of some other approaches. So it worked. It's good enough. So I will be writing the time and space complexity over here. So here our time complexity will be 2 to the power of n, big O of 2 to the power of n, because what we are doing is here it's O of n square for one time we did, plus this recursive function will have a time complexity of exponential time complexity of 2 to the power of n. So O of n square plus O of 2 to the power of n, so 2 to the power of n is exponential and it has a higher time complexity, so we are taking it as 2 to the power of n, as we are partitioning it at every point, either A or either this A or this B, like that. So if there is like n character, it will be 2 to the power of n. So let's also analyze the space complexity over here. The space complexity will be taking O of n square, so O of n square plus our solve function will at max take O of n. So our space complexity will be, turns out to be, wait a minute, because our result and current will also take some space here. So what about the result? So how many palindrome partitioning we can have? If we take all the palindromic partitioning, we can have here n string, then if you consider two strings, then it will be lesser only, obviously, for that. So space complexity for the result will also be O of n. So here the space complexity will be n square. That's it. Sorry, I run it again. So here we can say our time complexity is 2 to the power of n and space complexity is n square. And thanks for watching my video. I will come up with a better approach for this solution, and I will make a new video for this. And till then, thank you and keep practicing.